Hi everyone, this is Chris with Learn WebLogic Online, and in this lesson we're going to talk about WebLogic clusters. This is a really cool lesson. This is a really cool feature within WebLogic. I'm excited to tell you about it. Everyone probably knows what a cluster is, but in terms of WebLogic, clustering provides high availability and scalability for your environment. So what is a cluster? Well, a WebLogic cluster consists of one or more, preferably two or more, managed servers that run simultaneously and work together to provide increased scalability and reliability. So when you have a WebLogic cluster, you target managed servers to that cluster, and by placing them in the cluster, they become cluster members. They are part of a cluster. They are now clustered. In order to provide scalability and high availability and load balancing for resources and applications, we must target those resources now to the cluster and not the managed server. And that's what's shown in this diagram. If you take a look here, you can see that we have resources that are targeted to the cluster that are replicated to each of the managed servers, whereas on the bottom part of the diagram, we have non-clustered managed servers, and each one of these has its own unique set of resources that are not clustered. So if we lose one of these standalone managed servers, we have no recourse. We have no failure recovery. We have no failover. We have no load balancing because it's a single instance. Whereas in the top part of the screen, when a resource is deployed to the cluster and replicated across all managed servers, we now have automatic failover and load balancing of those resources. And so clusters can span multiple virtual or physical machines. They can cross network boundaries, and you can increase the size of a cluster without impacting the domain by simply adding a managed server to that cluster. And when you do that, WebLogic automatically deploys the resources and applications that were targeted to that cluster to that managed server. So what are the benefits of a cluster? Well, I've already mentioned scalability and high availability. And by scalability, I mean either scaling up or scaling out your WebLogic deployment. So we can add multiple WebLogic servers to an existing server, or we can add additional physical or virtual machines and running additional managed servers on those new machines. And so we can do that without impacting the runtime environment of WebLogic. And then there's application failover. WebLogic clustering supports failing over an application. So for instance, we can fail over a user's HTTP session if the application were to fail. So WebLogic supports session state persistence and replication, such that that user's session would be replicated to from a failed server or application to a healthy server. And any application processing that was going on could be failed over to another healthy instance as well. And then there's server and service migration. So WebLogic supports this notion of migrating whole WebLogic servers and services. So server migration is where you migrate a failed server in its entirety over to a healthy physical or virtual machine. And so that failed managed server can now be started on that new healthy machine. Whereas service level migration, such as a JMS server or a JTA service, or a singleton service, can be migrated from a failed managed server to an existing healthy managed server. So rather than migrating the entire managed server to a new host, I can migrate the services only on that failed managed server to a healthy managed server. And another capability of WebLogic clusters is load balancing. So WebLogic internally supports load balancing across JDBC, JMS, and EJBs. WebLogic also supports load balancing in terms of using a proxy or an external load balancer, whether it's hardware or software based. WebLogic actually has plugins that you can use to configure Apache or OHS, Oracle HTTP server, IIS, Netscape web server. And so there's load balancing at the HTTP session level as well that can be supported. And we'll actually demonstrate this in the lab. So what can be clustered? Oh, here's a short list of what can be clustered. We can cluster servlets and JSPs, EJBs, ARM objects, JMS resources, data source connections, coherence clusters and servers, and timer services. So there's really not much that can't be clustered. There are some exceptions. Singleton services are not intended to be clustered. They're singleton service, and there are only intended to be one instance of a singleton service running at any one time. WebLogic does support failure recovery, not failover. There's a distinction there. Failure recovery of singleton services. An example of that is a JMS server. So with JMS servers, we don't target them to a cluster. We target them to an individual managed server. And if we lose that managed server, we lose that JMS server. So there's a couple ways, there's a couple strategies there on how to manage failover for that. And I'll get into that later on in the lecture. So I want to talk about cluster communications for a moment. When you configure a cluster and you add a managed service to that cluster, those managed servers are known as cluster members. Those members need to talk to one another. They need to synchronize with each other. They need to understand what each member is doing. So it can determine health and state of an application. It can determine load and the general state and health of that cluster. So WebLogic supports two different communication protocols, multicast and unicast. So if you're not familiar with either one of these, multicast uses UDP, which is notoriously unreliable in the sense that there's no quality of service guaranteed for UDP traffic. So if a UDP packet is dropped, there's no attempt to resend that UDP packet. However, multicast traffic is preferable in the sense that is preferable for very large clusters, and I'm talking extremely large clusters, because of the reduced amount of network overhead. However, IP unicast uses direct TCP/IP sockets. This is far simpler to configure and is the default communication mode within WebLogic for clusters. So I recommend using unicast as much as possible, unless for some reason you've got some extremely large cluster. In the lab, we're actually going to configure a cluster to use unicast, and it's a very, very simple process, whereas multicast, we have to worry about addressing in multicast. So with multicast, WebLogic servers subscribe to a multicast address and port number and listen for cluster messages. And so with the multicast broadcast, messages are published to these managed servers. However, messages are not guaranteed to be received. So there is a slight risk that a managed server could miss a broadcast message. So to combat that, WebLogic actually has built its own reliable messaging protocol around UDP in an attempt to detect and retransmit lost messages. But I don't want to dive too deep in the networking aspects of multicast and unicast in this lecture. If you want to read up more on this and debate the finer points of which communication protocol to use, again, go to oracle.com and check out the online documentation for WebLogic 12c. And there's a document that discusses multicast and unicast and the specifics around cluster communication. So this is a very basic cluster architecture. You can actually various reference architectures for configuring your WebLogic clusters. This is the most common one. Let's focus on the combined tier architecture. And by combined tier, I'm referring to the web tier, the presentation tier, and the data tier within an application. So in some architectures, the web tier is separate from the presentation tier. And so you may have a separate cluster for the web tier. And if that web tier is static, mostly static files, static resources, and not compiled, like say JSP pages, that can be broken out from the application and deployed to say Apache. Okay, and we can have a cluster of Apache servers just for the web tier, but the presentation tier is all that business logic behind that web tier. That would be in a separate cluster, and perhaps the data tier could be in the same cluster or in another cluster as well. So you can decouple the various tiers within an application, but the application must be architected to support that. So in most cases, the simplest architecture is one where everything is deployed in a single cluster. You have a single enterprise application archive or archives or web archives, and those are targeted to a single cluster. So you've got everything from the UI to the business logic to the data tier, all deployed to a single WebLogic cluster. And then moving Ahead of the cluster, we have a load balancer that would sit on top of that. And the load balancer's responsibility is simply to load balance requests, user requests across those cluster members. And in front of that, typically there's a firewall. Now the firewall, some firewalls like the big IP F5 is both a firewall and a load balancer. So this is merely a logical representation. You could, like I said, with load balancers, so Oracle has a WebLogic proxy plugin for a variety of web services that are on the market. Apache is one of them. Apache is commonly used to load balance across WebLogic. So you can go to oracle.com and actually download these proxy plugins. So in the lab that goes with this lecture, we are going to use a servlet that comes with WebLogic to mimic a load balancer. So we can load balance servlets and JSPs, EJBs, RMI objects, and even JMS. And load balancing HTTP requests is done using a proxy plugin. So this is a module that Oracle has written that you would load into one of these web servers. So Oracle has one for Netscape, for Apache, for OHS, which is built on top of Apache, Microsoft IIS, and I mentioned that WebLogic comes with a servlet that can perform load balancing. I only recommend this servlet, which is called the HTTP cluster servlet, in a development environment so that you can test out the behavior of your cluster, of your application or resources within a cluster. I do not recommend this for production or even QA environments. If you're going to provide load balancing of HTTP requests, you really need a dedicated proxy or load balancer to perform that function. And so the default load balancing algorithm is round robin for these plugins. However, there are other algorithms that you can specify. There is such as server affinity, where repeated requests will be pinned to a particular server. But round robin is typically the one that most folks go with, where each subsequent request goes to a different server. And also these plugins support HTTP session persistence. And there's different types of persistence, and we'll get into that in just a second. And WebLogic also supports hardware load balancing. So I've personally worked with the big IP F5 to provide load balancing across WebLogic. And there are some requirements using an external load balancer, hardware load balancer, and that is it must support either passive cookie persistence, active cookie persistence, or SSL persistence. So if you have EJBs and RMI applications in your architecture, WebLogic does support load balancing across those EJBs and RMI apps through a variety of algorithms. There's round robin, which I mentioned earlier. There's weight-based, which is based on round robin, but it improves it by taking into account a pre-assigned weight for each server. You can assign each cluster member or managed server a numerical weight between 1 and 100. And the weight-based algorithm will take into account the weight assigned to that server. So if you have physical or virtual machines in your architecture that are not all the same shape, so they have different CPU and memory profiles, let's say you've got a slow one or you've got a fast one, you can define weights such that you can kind of steer WebLogic to use the beefier machine versus the slower one. And that's just one example of weight-based. And then there's random. Random is random. So all EJB and RMI calls will be randomly load balanced across all members of the cluster. And then there's server affinity. I may have mentioned this before. When you configure server affinity for your load balancing algorithm, WebLogic will attempt to pin repeated requests to that server. So wherever the original request comes in for an EJB or an RMI call, WebLogic will attempt to use that server for all subsequent calls, and that's server affinity. So load balancing JMS is supported only when we use server affinity with distributed destinations. We cannot load balance JMS across standalone destinations because messages that are published to a standalone JMS destination, such as a queue or a topic, are not available to other members of the cluster. And that's what a distributed destination is designed to do. When you have a distributed destination, messages are replicated across members of the cluster and they're available in the event of a failover or available for load balancing consumption. And as I mentioned earlier, JMS servers are a singleton service. They are pinned to a managed server. They are not targeted to a cluster. So in order to provide load balancing of a JMS server, we can target them to migratable servers. And I'll get into migratable servers in a minute here. And you can also establish transparent cluster-wide access by targeting the JMS connection factories to multiple targets within the cluster. And you can establish transparent cluster-wide access by targeting the connection factory to the cluster. How does failover work in WebLogic? Well, WebLogic needs to detect a failure. And there are two ways that WebLogic can detect a failure in a cluster. And the first one uses socket connections. So all members of a cluster monitor the use of IP sockets between peer servers. So let's say you've got managed server A and managed server B that are cluster members and they're talking to one another. If managed server B suddenly drops and managed server A is unable to reach it, managed server A will assume that that managed server B is no longer available in the cluster and there was a failure. So when there's an unexpected closure of a socket, that causes the peer server to be marked as failed. And so any services that were running on that failed managed server are now removed from the JNDI tree. If you recall, the JNDI tree is the Java naming and directory interface, and every resource and application is listed in that tree. And so when we try to use a data source or JMS destination, we have to look those resources up in a JNDI tree. So when the managed server fails, those resources are removed from that JNDI tree. And that failure will then be communicated to the rest of the cluster members so that they know not to route any traffic to that failed managed server. The second method for detecting failures in a cluster is the heartbeat message. Every cluster member broadcasts a heartbeat message every 10 seconds. And so regardless of the cluster communication, whether it's multicast or unicast, every server within a WebLogic cluster is listening for heartbeats. And so if 3 heartbeats are missed for a particular server, then that server is marked as failed. So for example, let's say managed server A is sending out heartbeats, and the other managed servers in the cluster are listening for those heartbeats. So we've got heartbeat number 1, and then 10 seconds later we have heartbeat number 2. And then after heartbeat number 2, there's no heartbeat 10 seconds after heartbeat number 2. And then another 10 seconds passes and no heartbeat, so that's a second missed heartbeat. And then 10 seconds pass again and we have a third missed heartbeat. And so after that third missed heartbeat, managed server A will be marked as failed. So we talked about load balancing for servlets and JSPs earlier using load balancers and proxy plugins. So failover for servlets and JSPs is also handled by hardware load balancers and the proxy plugins. So these plugins can detect when a server has been marked as failed within a WebLogic cluster. And so the proxy plugin is intelligent. It will remove that cluster member from its list of available cluster members. And so any incoming requests that hit the proxy plugin will not be routed to that failed server. And a lot of times, most hardware load balancers on the market support failure detection. And you can define rules around how to determine failure. Sometimes they can monitor a socket, and if a socket is suddenly closed, then it will mark that endpoint or resource as failed. But that all depends on the vendor that you're using for your hardware load balancer. So let's talk about session state replication for a second. As I mentioned earlier, WebLogic supports session persistence or session state replication, so that when a user is logged into an application on a particular server and that server fails, their session can be replicated over to a healthy server to preserve whatever information is stored in that session. So WebLogic supports in-memory session. So in-memory replication, when a session is established on a managed server, let's say managed server A, that session is then replicated on another managed server. And so we have a primary and a secondary managed server right now for holding session state information. And so if the primary server goes down, the user will be migrated over to the secondary server where his session had been replicated. WebLogic also supports a database-based session persistence, so we can actually configure a data source within WebLogic and have session information persisted to a database. And the benefit of that is that every cluster member has access to this database and would then have access to session state information. whereas in-memory replication is typically only replicated to one other managed server. And lastly, there's coherence. So we can use coherence web to perform session state replication as well. However, coherence web really is used for when you have a lot of data to replicate that's tied to a user's session. So when you've outgrown storing data in a user's HTTP session, because you really shouldn't be storing a lot of data in there anyway, you can use coherence web to replicate a lot of session data across your cluster. So now I want to talk about migration. WebLogic supports this notion of server and service migration. In a WebLogic cluster, most services are deployed homogeneously across all cluster members. Every cluster member in a cluster looks like the other cluster members in that cluster. So if I target resources and applications to a cluster, all the members get the same resources and the same applications, so they all look the same. And this allows to enable transparent failover from one server instance to another. However, JMS, as I've mentioned earlier, is one of these services that's pinned or targeted to an individual cluster member and not the cluster as a whole. So in order to support failure recovery of those services, not failover, but failure recovery, meaning that I can bring that service back online. I may not be able to recover or fail over that transaction, but I can at least bring the service back online. WebLogic supports failure recovery through migration. So with whole server migration, I can actually migrate a managed server from one machine to another machine. So if managed server 1 were to fail, we can do an automatic migration of that managed server from machine A over to machine B. And now managed server 1 is running on machine B. Service level migration is different in that we are not moving an entire managed server. We are only moving certain services. And we do that by targeting, say, a JMS server to a migratable target. And a migratable target is really just a managed server. This allows certain resources to be moved from managed server 1 in this diagram over to managed server 2. And service level migration is used for JMS and JTA and may be used for certain singleton services. However, the online documentation for WebLogic will describe the requirements that an application would need to meet in order to support a service level migration. If you have pinned services, it may be simpler to perform whole server migration and move a managed server from one machine to another machine. And these can either be performed manually or automatically. So that's clusters in a nutshell. Lab exercise number 10 is going to be a fairly long lab. We're going to cover a lot of topics in that lab, everything from creating a simple cluster to deploying resources to that cluster to setting up a proxy to load balance user requests. So it's a very hands-on lab. It's a fun lab. So stay tuned.